Alright, now for this thing called the unit circle. A unit circle is going to be a circle. Duh. Now let's imagine we drew a circle in the coordinate plane with a radius of 1. Now it asks us to write an equation here. I'm going to give you the generic equation here. We got x squared plus y squared equals r squared. Now in this case we're told the radius is 1. Let's just write that. So if we're filling this in the equation, it's going to be x squared plus y squared equals r squared, where r is 1, so it's going to be 1 squared, which is just 1. Now I'm going to draw a circle on this coordinate plane here. And I have that neat tool that draws perfect circles, so don't be too impressed. I'm going to shift it a little bit. That's pretty good. Now I'm going to just draw a random, maybe not so random, but I'm going to draw a radius going from the center to, I'll go a little lower here. Okay, so here is, well, let me finish this off. I'm going to make a right triangle out of it. Now on this right triangle, since this is a circle with a radius of 1, this longest side, this hypotenuse, is just a radius of 1. Now the length on this axis here, well, let me give you the coordinates for this one. The coordinates at this point here are x and y. We don't know what they are. Let's just call them x and y. Now we've got this right triangle here. The horizontal leg here, in this case, looks to be the longer leg. That length is just x. It's how far along the x-axis that point is. The vertical leg in this case is just going to be y. Now, thinking about this angle here, theta, the sine of that angle is going to be the y, or so the opposite side, in this case y, divided by the hypotenuse, which is 1. So we're just going to call it the y coordinate. The cosine is going to be the adjacent side to that angle, so it's going to be x divided by the hypotenuse of 1, well, in other words, just x. And the tangent is going to be the opposite side, y, divided by the x. Well, that one, we don't know what x and y are, so we can't reduce it. Hold this thought. We're going to come back to this and reference it in a little bit. Taking a look at these, we've talked about these angles before. The sine, cosine, and tangent of 30, 60, and 45 degrees. We've got all this information. So let me just briefly read through it. Sine of 30 degrees equals 1/2. Sine of 60 degrees equals square root of 3 over 2. And the sine of 45 degrees, after we simplified it, ends up being the square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Cosine of 60 degrees, 1/2. Cosine of 45 degrees, after we simplified it, square root of 2 over 2. Tangent, square root of 3 over 3 for 30 degrees. Tangent of 60 degrees is square root of 3. Tangent of 45 degrees, you end up with just 1. We're going to come back to this as well. That seems just kind of random. Here, oh my goodness, look at all those blanks. This is terrifying. What we're going to do is we're just going to go through this slowly. And if it's going too slow, remember, if you go to that gear icon in the bottom right, kind of towards the bottom right, like so down here, a little below this, if you click on that, there's the playback speed option. You can speed it up and slow it down as you need. So if you ever get bored of hearing my voice and you want to get it done as quickly as possible, you can speed it up. We're going to fill in a lot of information here. I'm going to break this down. We're going to start off with just our degree measures. So we've got 0 degrees, starting off here. Then the next one's going to be 30 degrees, 45 degrees, 60 degrees, 90 degrees. We're going to keep going. We've dealt with these angle measures before. Now we're going to go a little bit further. We got 120 degrees, 135 degrees, 150 degrees, and 180 degrees. Now, if you don't have those memorized, one way to pay attention to this is taking a look at the size of our angles here. If that's 30 degrees, and that's 45 degrees, and that's 60 degrees, well, that means this part must be an additional 30 degrees to get from 60 to 90. This must be an additional 30 degrees there as well. So 90 plus 30 degrees gives us 120. Now, there are a lot of patterns we could talk about here. I don't have time to get into them today. Maybe later in this week I'll post some of my thoughts about the patterns of these. And maybe you'll come up with some patterns as well. Keeping this pattern going, we've got a big jump there. So that's another 30 degrees. So we're up to 210 degrees. If you look at like the small jump here, I'm starting to talk about the patterns. Here we go. That's a small jump of 15 degrees. So we're going to add another 15 degrees. We're at 225. Add another 15 degrees for a small jump. We're at 240 degrees. Add another 30 degrees, because it's a big jump, 270 degrees. Okay, moving on, big jump. Add another 30 degrees, we're at 300 degrees. Small jump, add 15 degrees, we're at 315 degrees. Big jump, another small jump, add another 15 degrees, we're at 330 degrees. Add another big jump, 30 degrees, we end up with 360 degrees. We've completed a full circle, we're at 360 degrees. Okay, the next part we're going to do is radians. 0 degrees is the equivalent to 0 radians. Now, there's a couple that we know off the top of our heads. 360 degrees, one full circle, is 2 pi radians. That's what we talked about earlier in this section. Another one that we kind of talked about a little bit is 180 degrees. Well, 180 is half of 360, so it's going to be half of 2 pi, so it's going to be just pi radians. Okay, everything else we can base off of this. So, for example, 30 degrees. 30 degrees is 1/6 of 180 degrees. So it's going to be 1/6 of pi. So we're going to say it's pi over 6. 45 degrees. Now, this is one you might not know off the top of your head. 45 degrees is 1/4 of 180 degrees. So we're going to say it's pi over 4. Sorry, sometimes I use that bar as a fraction bar. Sometimes I don't. Let me go back and erase this one. I don't really care which way you do it. I just need to be consistent when I'm teaching. 60 degrees is 1/3 of 180. So we're going to say it's pi over 3. 90 degrees, half of 180. So we'll say it's pi over 2. Now, the next 3 of these is going to be a little trickier, but I'm going to talk about some tricks. 120 degrees. Now, you might know the ratio of 120 to 180, which is great. What I'm going to do is connect it to 60 degrees. 120 degrees is 2 times 60 degrees. So it's going to be 2 times the radius. So instead of pi over 3, it's going to be 2 times pi over 3. 135. Now, again, these 45s, you might not know the relationship of them. 135 degrees is 3 times 45 degrees. So it's going to be, instead of pi over 4, it's going to be 3 times pi over 4. 150 degrees. So I connect that back to 30 degrees, kind of the mirror image on the other side. 150 is 5 times larger than 30 degrees. So it's going to be 5 times larger than pi over 6. So we're going to say it's 5 pi over 6. 210 degrees, that's 7 times larger than 30 degrees, so I'm going to say I'm really far zoomed in my iPad, sorry. That's going to be 7 pi over 6. 225 degrees, that is, 5 times larger than 45 degrees, so we're going to say it's 5 pi over 4. 240, missed the degree symbol there. 240 degrees is 4 times larger than 60 degrees, so it's going to be 4 times larger in radians. So instead of pi over 3, it's going to be 4 times pi over 3, or 4 pi over 3. Now, 270 degrees is 3 times 90 degrees. So we're going to say it's 3 times that pi over 2, or 3 pi over 2. Keeping going. 300 degrees, I always go back to that first quadrant. It's 5 times larger than 60 degrees, so we're going to have to do 5 times larger than pi over 3. So we got 5 pi over 3. 315 degrees, again, it's related to the 45s. Not everybody, it's the 45 degree multiples are a little harder. 45 times 7 gives us 315. So we're going to do pi over 4 times 7, or 7 pi over 4. 330 degrees is 11 times larger than 30 degrees. So we're going to do 11 times pi over 6, or 11 pi over 6. Okay, we're about halfway down. Now, this is the unit circle. The unit circle, remember, has a radius of 1 unit. And I'm going to draw this on here. This length right here, going from the center to the outer edge, is 1 unit long. That's on the x-axis. That means its x-coordinate is 1. Its y-coordinate is going to be 0. It's gone 0 up. Now, picking out a couple other easier points on here. 90 degrees, straight up. 1 unit out. Now, it's 1 unit straight up. So that means its x-coordinate is going to be 0. Its y-coordinate is going to be positive 1. At 180 degrees, or at pi radians, same thing. It's going to have a radius of 1 in that direction, but it's going to be in the left direction, so it's going to be a negative 1 for our x. Still 0 for our y. 270 degrees. If we're going to go down that direction, we're going to be 0 over... Oops, sorry, I'm in shape mode. We're in 0 over in the x-axis, but we're going to be down negative 1. Okay, that was the easy part of the coordinates. Let's draw a right triangle at 30 degrees. Now, we talked about this. We got x coordinates and, y coordinates for all these. I'm going to flip back 2 pages a second. You can stay here on your notes or whatever. I'm going to go back. Taking a look at what we talked about here. On this unit circle, the sine of an angle is the y coordinate, the cosine of the angle is the x coordinate. Let me go add that to the upper right corner here. I'm going to say the cosine is going to be the x coordinate, the sine is going to be the y coordinate. So, focusing on particularly 30 degrees, the cosine is the x coordinate. Well, let's find out what the cosine is. Hey, look at that. We did that in the previous page. So the cosine of 30 degrees is the x coordinate. So this has an x coordinate of square root of 3 over 2. The y coordinate is the sine of that angle. The y coordinate is the sine of 30 degrees, which is 1/2. See that right there. Let's add that in. So that's 1/2. Okay, let's move on to the next one. 45 degrees, aka pi over 4. Same pattern. The cosine is the x coordinate. Going back, the cosine of 45 degrees is square root of 2 over 2. Going to the sine of 45 degrees. Sorry if I'm zooming in. Remember, you can always pause or slow down the video. Or if you need to speed me up, you can always do that too. Next up, the y coordinate for 45 degrees is the sine of 45 degrees, which is also the square root of 2 over 2. Cool. The cosine of 60 degrees is going to be the x coordinate at 60 degrees. So the cosine of 60 degrees is 1/2. The y coordinate at 60 degrees, again, the sine is the y. So we go to the sine of y, which is the square root of 3 over 2. Cool. All right. So quadrant 2, we need to find a table that has the sine and cosine of 120 degrees. I don't have that, or I never gave you that. Well, shoot. What do we do? Give up, go home, cry in a corner? Well, you're probably already home, but let's just not cry in the corner part. We can figure this out. What I'm going to have you do, get familiar with this first quadrant. These 3 coordinates are going to come into handy. Taking a look at 120 degrees. Taking a look at the relationship of 120 degrees to 60 degrees. They're mirror images. This point here is the same distance away from the y-axis as that point. They're mirror images. That was a horrible demonstration. Let me try that again. This point here and this point here are mirror images. They're the same distance away. One just happens to be on the left side of the y-axis, which means its x-coordinate, if this is a distance here of positive 1/2, this distance here is going to be a distance of negative 1/2. So its x-coordinate is going to be negative 1/2. Now those 2 points are at the exact same height, so the height is still going to be positive square root of 3 over 2. Doing the same thing for 135 degrees. It's the mirror image of 45 degrees. So the x-coordinate is going to get changed to become a negative. It's on the negative side. The height, the y-coordinate, is still the same. For 150 degrees, it's the mirror image of 30 degrees. So its x-coordinate is going to be the negative square root of 3 over 2. And its y-coordinate is at the same height as 30 degrees, so it's 1/2. So even though we don't have a table for that, we don't need it. If we've got the coordinates from the first quadrant, we can just do the mirror images. So, looking at quadrant number 3 here, remember this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Quadrant 3, a couple different ways you can talk about this. I said I wasn't going to get into patterns, but I can't help it. So when I think about this, if I'm going through this, I have this pretty well memorized. I've taught this like 1,000,000 times now. Maybe not quite 1,000,000, but at least 900,000 times. I still often just go through, okay, use this mirror image to this mirror image. It's going to have the same x-coordinate, so it's still going to be negative square root of 3 over 2. But now the y-coordinate's no longer on the positive side. It's the mirror image. It's going to be negative 1/2. For 225 degrees, aka 5 pi over 4, it's the mirror image of 135 degrees. So it's going to be negative square root of 2 over 2. Also, for the y-coordinate, still negative square root of 2 over 2. For 240 degrees, aka 4 pi over 3. It's going to be the mirror image of 120 degrees. So it's going to be negative 1/2 negative square root of 3 over 2. Quadrant number 4. When I think about this, I either relate it to the coordinates over here, so like that mirror image to that, or you can go back and relate it to the mirror image from quadrant 1. So like this height here and this height here. It doesn't matter how you do it. I'm just going to kind of go through and fill this out without talking about it quite as much. We've got positive 1/2 negative square root of 3 over 2, positive root 2 over 2, negative root 2 over 2 for the y coordinate, positive square root of 3 over 2, negative 1/2 for the y coordinate. Folks, there are so many patterns to this, I don't have time to get into all of them right now. I'm thinking later in this week I'll probably post a video about me nerding out about the unit circle. The unit circle is up there in terms of my favorite things, in terms of mathematical practices and mathematical concepts. Right up there with Pascal's triangle and that quadratic formula thing that you guys all like. What I'm going to have us do is I'm going to have us use this to quickly come up with the sine, cosine, and tangent of some angle measures. So here's our practice for this. So we're asked to find, first of all, the cosine of 225 degrees. Going over here, 225 degrees, that's here. The cosine, according to this legend up here, is the x-coordinate. So the cosine at 225 degrees, we look for the x-coordinate at 225 degrees, and we end up with the negative square root of 2 over 2. And that's our answer. Ta-da! Now, the sine of 315 degrees, we'll figure out, okay, 315, that's over here. The sine's the y-coordinate of that angle measure, and that also is, coincidentally, negative square root of 2 over 2. The cosine of 4 pi over 3, going to radians. 4 pi over 3, find that on the unit circle. 4 pi over 3, that's down here. The cosine is the x-coordinate, so that's going to be the negative 1/2. Tangent of 180 degrees. So we go to 180 degrees, we stare really hard at it, and then we realize that we never talked about tangent. Yes, we did. We talked about that earlier. Let's go back. Tangent of the unit circle is the y-coordinate divided by the x-coordinate. We talked about that earlier. So we're going to take the y-coordinate, 0, divided by the x-coordinate. So we got 0 divided by negative 1. We end up with 0. Yay. Well, that's not super exciting. Let's try a different tangent. Tangent of 5 pi over 6. Tangent of 5 pi over 6. We find 5 pi over 6. Where is that? I am making a mess. Let me clean this up a little bit. And I'm not going to do it all. 5 pi over 6. Oh, okay. That's over here. The tangent, we're going to take the y-coordinate, 1/2, divided by the x-coordinate, negative square root of 3 over 2. So we have 1/2. Sorry, I'm making a mess. Let's try it again. 1/2 divided by negative square root of 3 over 2. That is messy. Dividing by fractions. Yuck. Let's see if we can change that. So instead of dividing by a fraction, remember, instead of dividing any time, you can multiply by the reciprocal of what you're dividing by. So we're going to multiply by the reciprocal of negative square root of 3 over 2. So I'm going to say it's negative 2 over square root of 3. Going through this, we can actually, let's just multiply it as is. 1 times 2, throw that negative out front, is 2. Denominator, 2 times the square root of 3 is 2 times the square root of 3. We can clean that up a little bit. Those 2's cancel out, they both become 1's. So we end up with negative up top. We got 1. Denominator, 1 times the square root of 3 is just the square root of 3. And that's as simplified as it gets. Or is it? Remember, rationalizing your denominator. You don't want to leave square roots in your denominator. So to get rid of that, what we got to do is multiply both the numerator and denominator by that irrational piece. We're going to multiply the numerator and denominator by the square root of 3. So the numerator, 1 times the square root of 3, is the square root of 3. I have a negative sign out front. Divided by the square root of 3 times itself. In other words, the square root of 3 squared is just 3. So our final answer on that one, the tangent of 5 pi over 6 is the square root of 3 over, the negative square root of 3 over 3.